Hi guys, I finally got around to making the PowerPoint and all of the supplemental stuff to go along with it. I hope this helps you guys a lot, especially with understanding, because if you understand it, you'll remember it, you'll memorize it quicker and remember it faster when somebody asks you about it. So, um, just gonna go basically do a very short review of the um, last 2 points between versus within subjects. Um, the they also are known as between and within groups, so you'll hear those interchangeably. And then the last bullet point: independent groups design versus within groups design. Um, so think of between groups as something, a sample of two completely different, um, a sample from two completely different populations. So um, between, you're looking at the differences between two groups. So just keep that in mind, the between, um, and this applies to studying multiple groups. So between groups, um, between subjects also, it's like participant 1 is in group 1 and participant 10 is in group 2. They're just completely different participants, so they're not going to be in the same condition basically. uh, Within would be like kind of like before and after. So within subjects, you're using the same subject another time. So you're keeping it within. You're not comparing two groups, you're just looking at a before and after for 5 participants. Um, Independent groups design, um, that would be between subjects. Your groups are different from each other, they're independent of each other, so keep that in mind. They're not the same. They're in two different conditions. For example, um, they're not the same. Within groups design is basically going to look at the before and after, um, how something changes for this participant after taking um, a multivitamin or something. So for the tests that we have to do, I just kind of wanted to explain it real quick. The independent samples is, remember, looking at two different um, groups uh, and conditions, essentially. So your samples, they're both going to be different from each other. Um, the paired samples is the before and after the uh, the stimulus or whatever it is. So paired samples would kind of be like within subjects. You're looking at a before and after. So on the homework, the first test, you guys were supposed to do an independent samples t-test, but only on time 1. The second test, we needed to do a paired samples t-test, which would be the before and after um, the insult or whatever the condition. And then the third test, it's going to be an independent samples t-test again, but only with time 2. I know I told some of you to select both, but you don't really need to select time 1 when you do the third test. Okay, so the graph, there was a lot of confusion, I guess I want to say, on what it should look like. Um, some of you were on the right track. and I didn't really give away too much because I wanted you guys to give it a try yourselves, what kind of graphs you would come up with. There's one more step that we needed to do. Uh, and when you go to graphs on SPSS, you're going to click Chart Builder. This window will pop up, and then you can ignore what it says or learn from it, whatever it is you want to do, just hit OK. And then after a few more steps, your chart builder should look like this. So I'm going to go over how to do this after I'm done with this little brief PowerPoint. So for interpretations, the independent samples t-test is basically going to tell us if there's a difference between the two groups or not. If the p-value is significant, less than 0.05, then yes, there is a difference between the two groups. I just wanted to point out that groups is referring to the two different separate samples that have been recruited for a study. And this kind of helps me at least remember what's going on when I see a group versus a condition. If the result is not significant, then there's no difference between the groups. So, for example, a group could be, in my SPSS example, you'll see university. The two groups within university is going to be, let's say, Harvard and Yale. So those are your two different groups. Assuming there's normal, the distribution is normal, and we're meeting all those assumptions. We're not violating any of them. The samples won't be different, even though one group is from Harvard and the other is from Yale. You're gonna see that if everything is going right, or if everything works the way it should, there's a they're both normally distributed. They're similar, but whatever they're going to be tested on, obviously the results are going to be different depending on what it is we're testing. So I'll kind of point that out later on when we run the analyses. Paired samples t-test, if the result is significant, then there's a difference between the two conditions. And for conditions, I'm referring to like the time 1 and time 2 recording of the before and after the treatment or the stimulus or whatever. So in my SPSS example, the paired sample is going to be before the event and after the event. If the result is not significant, then there's no difference between the conditions or the before and after, or time 1 and time 2. Okay, so the successful random assignment, I really apologize for the people I told to do the Levine's test or to read that. But there's another way that I'm hoping is a lot easier to understand, to determine the equal variances or the equality of variances across both groups and conditions. So I'm going to show you the SPSS part. Hopefully it's helpful. Message me or email me or let me know during lab if all of this is helpful. So let's get started. Okay, so I have a cute little fake experiment. The Associated Students Office at CSUN wanted to conduct an experiment. They wanted to see if the level of the students' campus pride, um, or where it was actually. They wanted to know how high or low it was. Then they wanted to see how much their pride would change after having a completely free campus event. The event was going to have a bunch of fun activities, and it was going to expose students to a lot of the resources on campus. They also wanted to expose the students to information about how to get the most out of their education at the school. Sounds like a delightful event, right? The AS office had a template set up of how they were going to conduct their experiment. Before they began, they contacted the AS office at UCLA. CSUN AS told them what the study would entail, and they decided to participate in the study. They referring to UCLA, sorry. The days had come and gone, and now they're finished with their study. Do the campus pride ratings before the event differ between CSUN and UCLA? Was there a significant change in pride from before the event to after the event? Which university did the best at improving their students' pride? Include a graph showing the differences between both universities after the event. So the prompt kind of sounds familiar, right? I'm hoping it does sound familiar for you guys because this is very similar to Debbie's example. I just made up my own data and just go with it. Okay, so in SPSS, I have my data. One thing that I want to point out is for university, I have it coded with zeros and ones. You're going to see that a 0 equals CSUN and 1 equals UCLA. Under variable view, open up this label right here. CamPre 1 is Campus Pride at time 1, and CamPre 2 is Campus Pride at time 2. They're both scale measurements. There's an error that you guys might encounter, and I'll point it out when I'm doing the graph part. Okay, so the first test, we're going to go to Analyze, Compare Means, Independent Samples t-test. We're going to move university to our grouping variable, hit Define. So group 1 is CSUN. So CSUN's coded as a 0. That's what I'm going to put there. UCLA is the second group and coded as a 1. So I'm going to put a 1 here, then hit Continue. And then I'm going to move Campus Pride time 1 to the test variable. And then I'm going to hit OK. So this is what I got. You'll see that the sig value is greater than 0.05. So my UCLA group and my CSUN group are similar. T-test, what an independent sample t-test does is look at differences between means. So even though I told you to look at the sig value over here, it's greater than 0.05. You're going to see that the means are fairly consistent across both groups, or similar. So if your means are close, fairly similar, then the variances aren't going to be that different either. They're going to be fairly or moderately, I'm just using the wrong words right now. The variances are going to be almost homogeneous, so they're going to be almost the same. So that's why we could interpret that first part of the assignment in this way. So looking at my data, let's space these open a bit. Oops. Okay, so this is Cam Pre 1. You're going to see that for CSUN, they're averaging around, I don't know, like 91, 90, or something. Um, and then for UCLA, they're averaging around 89 or 90. Not too sure. But it's a nice mix, but there's equal variances. So whenever you run the t-test and you're looking for significant differences in means, um, you're gonna see that it's not significant. All of this, there are no significant differences in the means. So that means their variances are almost the same. So if the means aren't that large and they're close to each other, then the variances aren't going to be that large, but they're going to be close together. So I'm hoping that I didn't butcher the explanation, but if I'm still unclear, I will map it out for you guys. Um, Hopefully create like a flow chart or something that'll make more sense. Okay, so we see that it's not significant. There's no difference in the means, no significant difference in the means, therefore there's no significant difference in the variances. And this is especially important. Remember, for time 1, we're only looking to see if the means are um, we're trying to see if they're significant or not. If the differences in the mean are significant at time 1, then it's suggesting that there could be uh, a difference in the variances between the two groups. So over here, it's 0.608 greater than 0.05. No differences in means. The variances are fairly similar. So I'm going to go ahead and try to write that up for you guys to show you what that looks like. So, and remember, please use your own words. Try to change it. I don't want to see high similarity points or percentages. If I continue to see them that high, I think I'm gonna maybe deduct points or something. But I really want you guys to try to make it sound like your genuine self with like 5 years of research experience or something. I don't know. Okay, enough yapping. So to write this up, we're gonna say there was successful random assignment because there was successful random assignment because the variances were fairly homogeneous, or you can say fairly similar, whatever you want. The variances were fairly homogeneous. There was no significant difference between CSUN. I'm gonna include the means now. Italicize that M space equals, then space again. The mean for CSUN is 90.93. We're going to put a comma. Now we're going to italicize the SD. Make sure you turn the italics after you finish typing the letters. So then we hit space, equal, space, and for CSUN it's 1.75, close it off, and UCLA, same thing. Okay, so there was no significant difference um, between CSUN and UCLA. Then we can put the rest of the information that we need, like the T. It's going to be 28. So the T is italicized. Then we put a parentheses right after 28, and then close it. The parentheses and the number in here is not italicized. Hit space, hit equal, hit space. For my data, it's 0.519. And then we're going to include that 0 in the front because T values and F values can be higher than 1. If it was a correlation, then we don't have to include that 0 because the highest number is 1, versus a T and F could go up to 18 or 100 or any other number. Okay, so back to this. I put the T value, I'm going to put a comma, and then I'm going to italicize the P, and I'm going to put it the exact number, so I'm going to put equals 0.608, and then end the sentence. So that's the first part. You can definitely move things around. You can break this up into more sentences. You change up the words, do whatever you can so that it's not showing up as like 40% similar or 30% similar. Okay, so going to back to the SPSS data and output, we're going to do analyze this time because we're going to do the second part. So we're going to go to compare means, paired samples, t-test. The variable 1 is going to be CAMPRE 1, and then variable 2 is going to be CAMPRE 2, and then just make sure there's no options for means and stuff. I'm going to check that, then hit OK. So the means and standard deviations are already included. You're going to see this correlation over here, and then you're going to see the paired samples test output. So this is going to see if there's a difference with the before and after. My example ended up being, I guess, too similar because I have a sig value of 1 and my mean is 0. So in your guys' output, it would look a lot different. The sig value wouldn't be 1. You'd have a t value, you'd have a mean. So I might just tweak the variables or the data real quick just to see if I can give you a more concrete example. So we're going to put a couple more 91s or something, I don't know. It's looking at time 2. So this is probably where I needed to make the change. 87. Okay, now it should work a lot more in my favor. Okay, clean that up real quick. Analyze, compare means, independent samples t-test. Oh, sorry, paired samples. t-test, hit OK. Okay, so there you go. Now it worked out a lot better. I actually have something to give you guys now. So remember, this is trying to see if there's a difference from time 1 to time 2. Paired samples t-test / within subjects. Okay? So it's the before and after part. We are going to go back here to the document and get started on writing the other interpretation. So there was no significant difference between time 1 and time 2, or in my case, between before the event and after the event, but that kind of sounds weird. Okay, anyway, put the comma, then report my t-value, t 29 equals negative 1.65, comma, p 0.109. I noticed this mistake had been made a few times on some of your papers. If this is 0, don't put p equals 0 or 0.00. Put p less than 0.001. And I don't know if you guys notice the difference between the degrees of freedoms for the independent and the paired samples. But I just feel obligated to bring it up just in case. In the independent samples, you have 2 different groups. So it's going to be n minus 2. And then we have 28 for the independent samples. For the paired samples, it's going to be n minus 1. So your before and after make one pair. Since this is a within subject design, you're not comparing different participants. You're just looking at a time 1 and time 2 of the same people. So n minus 1, 30 minus 1, we get 29. Okay, so that's the result for that. Also, this is part of the result. We need to report the mean and the standard deviations. So you're going to write something like, let's see, before the event, the campus pride okay, before the event, the average, no, sorry, I'm just having a brain fart. Okay, so let's do this. Between the 2 universities, the average of campus pride did increase. The average of campus pride ratings did increase. Did increase after the event, and then you could do something like you can do okay, so between the two universities, average of campus pride ratings before the event did increase after the event was over. Between the two universities, average of campus pride ratings for the event increased. Okay, so solve that dilemma in my, I'm hoping, correctly. Then we're gonna do open a parentheses. Again, you don't have to write it this way. You can do comma, whatever you like. Mean is 90.70, and the standard deviation is 1.70. And M equals 92.7, standard deviation 6.48. I'm actually going to get rid of that parentheses. Put a comma. So we've got the mean equals 90.7, the standard deviation, and then respectively. So this part is corresponding to the before, and then this part is corresponding to the after. So that's the interpretation / report for a paired samples t-test. Last analysis for independent samples t-test. We're going to go to compare means. Again, independent samples t-test. Instead of CAMPRE-1, we're going to go to CAMPRE-2. This is the equivalent of the time 2 or the after, whatever. Hit OK. And then we're going to get this output now. We see after the event there is a significant difference between the means. And then we'll be able to determine which school had more campus pride or have a better better understanding, kind of like a correlation where we can't assume causation. But t-tests definitely help us get closer. So we're going to do the write-up now. Scoot this over this way. Okay. So there was a significant difference between the groups after the event. T, then put the 28 equals 14.11, P less than 0.001, period. One thing that I wanted to point out, the random assignment thing, it doesn't apply to time 2. We just need to worry about it at time 1, because we see here that the means are significantly different, so that's going to affect the variances. But in this case, we already see that the variances are fairly similar. So yeah, now we're going to have to report the means. We're going to say ratings of Campus Pride were higher at CSUN mean 98.67, standard deviation 1.95 were higher at CSUN compared to UCLA. 86.73 and then 2.63. Okay, so that's the final interpretation for that. You're gonna see that the means are way different. For UCLA, before the event, the mean was 90.60, and after the event, the mean is 86.73. So that must mean UCLA sucks. Just kidding. In this example, it would mean that that maybe UCLA didn't have a good job at having this event, or they didn't provide information that would help the students utilize the resources on campus, etc. So we're going to go on to the last part of this assignment. We're going to go to our output, hit analyze, or sorry, go to graphs, go to chart builder. You're going to get this pop-up, hit OK, or you can pick don't show this dialog again. You're going to see this pop up. What we're going to do is grab this, this bar graph down here, click, hold, and drag to this larger white box. The error that I wanted to point out to you guys was you're going to see that, or it might be, I don't know if it's going to happen to you guys or not, one of these is going to show as a nominal variable, and you need both to be, you need both of them to be interval. So in order to make sure that happens, you're going to right click on it and then hit scale. And then same thing for this one. You're going to right click, hit scale. We're going to move our condition onto the x-axis. So grab it, hold it, drag it down there, and then we're going to drag Campus Pride time 1 to the count over here, or the y-axis, and then we're going to click and hold Campus Pride 2 and drag it to the same place, but you're going to see this plus sign with a small rectangular box. Put it there, and you'll get another window popping up. Just hit OK, and then you're gonna get something that looks like this. One last setting to change is go to the x-axis, parentheses bar 1. If you go down here where it says small empty categories, click on show only categories present in the data and hit apply, and then you're gonna hit OK, and then this is what your graph, or in my excuse me, in my case, my graph is gonna look like this. So you can see that UCLA before their event, the ratings were on average this high, and then after the event it went down because they suck. Again, just kidding. And then CSUN, it was lower, and after the event it increased. So that's the graph that you're gonna have to include that's being asked of you at the end of the assignment. So I'm hoping this helped. This is my own example, but it's very similar to Debbie's, how you guys will be moving things around, where which variables go where, And if you have a hard time, then um, try to get a hold of me, but know that I won't be. I have a really tight schedule tomorrow, so maybe one of the other TAs are available. Again, I hope this is helpful. See you guys on Thursday and Friday, and have a good night.